Hello everyone, thanks for coming to this talk. I'm Guanlin Chen from Tianjin University. Today I'm going to present our method called Tell Me the Evidence, Dual Visual Linguistic Interaction for Answer Grounding. This is a joint work by ByteDance and Tianjin University. Well, the vision query answer grounding task mainly contains two objectives. The first is just like a common VQA task, which is answer the questions about images. But answer grounding also requests the algorithm to highlight the relevant positions in the image. In other words, we need to segment the target area. The VizWiz dataset provides us four kinds of information: the images that work as visual inputs, the masks which are the answer grounding areas, the query text related to the corresponding image, and the answers to the questions. There are many traditional answer grounding methods in the field of VQA, but most of the previous grounding methods are the detector-based. For example, RefCoco provides bounding boxes as annotations for such VQA grounding tasks. They usually rely on pre-trained detection models to provide object features. The drawback of this kind of methods is that they usually have low flexibility for the objects not in the predefined vocabulary. Recently, a few works try to get rid of these limitations in a weakly supervised or attention-based fashion. But neither the answering accuracy nor grounding accuracy satisfies the requirement. To overcome the challenges of answer grounding, a critical perspective is how to reconcile the visual-linguistic interaction. Many current methods utilize Visual-Linguistic Pre-Training framework for VQA tasks. For example, the blip and the flamingo. The VLP often contains large-scale transformers as backbone and uses web-scale data. It's a better way for visual-linguistic alignment and fusion, which can significantly improve the VQA accuracy. However, VLP utilizes text generation, which means it concentrates more on the linguistic side, which ignoring visual interceptability such as grounding. Now, the key point is how to maintain the visual interpretability of the model while understanding the linguistic information. We propose DaVI, a novel unified framework for both linguistic answering and visual grounding via two visual-linguistic interaction mechanisms. We can see the pipeline of our method on the right, except the basic visual decoder and linguistic decoder. We propose the visual-based linguistic encoder and linguistic-based visual decoder. The VLE understands questions incorporated with visual features and produces linguistic-oriented evidence for answer decoding. And the LVD focuses visual features on the evidence-related regions for answer grounding. Here is the detailed framework of DaVI. We can see the VLE incorporates the visual features by adding a cross-attention module and replace the K and V with visual features. The LVD focuses visual features on the evidence-related regions by using the visual features as Q, and linguistic-oriented evidence generated by VLE as K and V, which achieves deep visual-linguistic interaction for both linguistic answering and the visual grounding part. Except the VizWiz dataset. Before training, the visual encoder, visual-based linguistic encoder, and linguistic decoder in DaVI are pre-trained on the web-scale dataset from blip. During training, explosional moving average is used for integrating the parameters. After training, the models trained with different hyperparameters are also weighted and assembled. Compared to LVAVT, which is the state-of-the-art method using single interaction paradigm for referring image segmentation, DaVI successfully achieved a 4.24% IOU improvement without model ensemble, thanks to the design of dual visual linguistic interactions. To sum up, we proposed DaVI for answer grounding, which utilizes the VLE and LVD for visual linguistic interaction to unify the linguistic-oriented answering and visual-oriented grounding. And DaVI ranks the first place on the public leaderboard of VizWiz Answer Grounding Challenge. Thanks for listening.